So this is page 199 of the note spiral. So page 199 of the note spiral. And this is scenario 2 for hypothesis test for 2 sample proportions. So an automobile manufacturer randomly assigns cars to 2 distinct assembly procedures. In a sample of 350 cars coming off the line, use the first procedure. There are 28 major defects, while a sample of 500 of this from the second shows 32 defects. Is this significant at the 10% level? So P1 proportion from the first process, P2 defects at the second process. And they want to know, is this significant? There was no direction given. It didn't say less than or greater than. So we're going to go with not equal to. So the true population proportion of cars with defects with the first assembly procedure, the true population proportion of cars with defects with the second assembly procedure. Step 1, random assignment is given. Reasonable to assume independence as the treatments are randomly assigned and one assembly procedure should not impact that of the others. And we have, and you'll notice I did not address whether or not it was less than 10% of the population. We do not have to do that for random assignment. For random assignment, you do not have to, for experiments, you don't have to do it. And so we did not do so. So we do need to make sure that we're large enough. 28 is greater than 10. And 28 with major defects out of 350. So then our next thing is, how did we get Q? Well, Q was 350 minus 28 is 322. That's greater than 10. First sample is large enough, first process. The next one, we had 32 defects out of 500. So 500 minus 32, and that gives me 468, is also greater than 10. So both samples were large enough. All right, so P hat 1, 28 over 350 is 0.08. P hat 2, 32 over 500 is 0.064. Then we need to do our P combined, or our P pooled, if you prefer. We had 38, and remember, we only pull for hypothesis test for proportions. 28 plus 32, these are the number of defects, and 350 plus 500. So we ended up with 60 out of 850 is 0.0706, 0.07058. So we're plugging in. This is P hat 1. Here's P hat 2. And by the way, you have to memorize these formulas, all right? I will not see that on our test because you're allowed to use your notes, but on the AP exam, they're not giving you this. So P hat 1 minus P hat 2. Our combined, or our pooled value, which was 0.0706. 1 minus 0.0706 is 0.9294. And of course, this one and this one are exactly the same. And then this is N1 and N2. And I wrote something not quite right. This should have a hat. Those are not P's. Those are P hat 1 and P hat 2. These should not have hats. This is population proportions. This came from our sample, so these are our sample proportions. Please note, when I wrote my sentence, I have it 2 times. And the reason being is this was a not equal scenario. So here we go. We're going to go ahead and run this thing. Stat test 2 proportion z test, which was number 6. And we had 28 out of 350. And our X bar 2, X2, I should say, was we had 32 out of 500. One thing is very important, guys. You need to make sure that you're showing this work. You have to show P hat 1 and P hat 2. All right, you are required to do that. Calculate. So I end up getting 2 times this is 0.37. That's a pretty large p-value. Now let's go through what we see on the screen. We see our Z, we see our p-value, we see p hat 1, we see p hat 2, and this is our p pooled or p combined. Do not just use p hat. This is p pooled or p combined, okay? And you have to show that calculation as well. So this calculation I'm putting a star by, this one by a star by, this and this, you're going to have to show those every single time. So 0.37, 37 is definitely greater than 10. So we're going to fail to reject the null. There is not sufficient evidence that alpha equal 0.1 to suggest that the true population proportion of defects has changed or is different from the first assembly method to the second, right? And if you didn't want to use change, you can put is different. Either one is acceptable. From our study, both assembly methods appear to produce the same proportion of major defects. Obviously, as a result, the cars will fail, people will die, but at least we'll know that the proportion will be the same regardless of the assembly method. All right, and we will do one more of these in the next one.